I just want to finish off the state machine that we did last time. I just want to flesh it out a little bit just to show you guys how you can build on it. So I want to finish off this dash. What I've done differently here, you'll notice in our physics function, I've put the friction of the character in here. And I've also moved this whole player class. I'm still inheriting from the NPC. So I've had to import the NPC from characters where our player was before in here. Because what was happening when I was using the same state machine for the NPC and the player, if I clicked dash, obviously both would dash because they're both using the same state machine here. So we can actually get rid of this one. I don't need the NPC to dash, so the basic NPC state machine is idle and run. That should all we need for the most basic one. And then if I go over to player, I've just put it in a different file. So it still inherits, still the same as before. We have to instantiate the self.state so it actually calls this state machine now. So don't make the mistake I did. I'm wondering what was wrong for a long time when I did that, and I didn't put this in here. And it was just inheriting from the NPC's class. Nothing was happening when I added extra states in here. So instantiate this and it will start calling from here. And then in turn, these will start calling the other states in this file. So this is how I would do it. I'd do a different file for each character with my base NPC in here and then player in here, and start building it that way and have the state machine in the same folder. But that's up to you how you want to do that. So let's build on this. So you'll notice I've given it an init method, and I've inherited from idle. So when you change state, I want the animation frame to start at 0 for each one, otherwise it can look a bit weird. So I just do that by instantiating in the idle class, then inheriting all those instantiated variables from idle in the run and subsequent classes. So that will be frame index of 0 for the animation at the start of every state. So this is what we had before. Let's run it. Let me just explain this. I want to pass a different friction in here. So if we keep the standard friction, as soon as we start calling this physics method in our dash, it will move really, really fast if you tell it to, and then the standard friction takes over and slows down. So I want more control in each state for this. So if you look back at where this is from, the physics method, it's inherited from the character, the NPC. Just here, all I've done here is passed it in as another parameter. Let's call it friction. So instead of self.friction here, which is a variable we can use, so let's call that the standard friction. Let's keep it at fric because that's how I've called it elsewhere. So it's minus 15 as standard. So we can use that for idle and run. It did look quite okay for what I was using it for, but you can fine tune that. You can change it. And then we don't have to change friction all the time because the physics is called in the state machine. So it'll just give it the relevant friction for whatever you define in the state machine. So we'll come back to our player. And then here you've noticed I've used the standard character.friction, which is minus 15 for the run and the idle. And we can just use different friction values now. So that makes it a bit more scalable again. And sort of fine-tuned to what you need. As I said, there's more code in these state machines, but it does give you a lot more fine-grained control over what your character's doing, and a lot less bugs to sort because you only have to look inside the class itself for any bugs. it's totally independent of any other class. Okay, so 3 seconds was quite a long time. Let's just call it 1 second for the timer for the dash. And we had the attack animation. I didn't have this before, but if you remember in our animation tutorial, I could just call this false and it would not loop. It would just stay on the very last frame. So let's run this, see what we've got. Obviously the velocity when we dash should just stay at 0. There's no movement being called here. So nothing will happen until it comes out of the dash state when the timer is reduced to less or equal to 0. So let's run it. So I'm moving around. It's my left mouse click. It stays still. So I'm holding right mouse click, sorry, and it stays still for 1 second. I'm still holding down that key. So that's perfect. I'll change my variables here while I was debugging. So this was just me debugging the direction of the dash. So don't worry about all these numbers for now. As we've said before, you can put whatever you need in here to debug your own game. So you can ignore what I've got here for now. That's a handy one when you're doing this, the state. Just show what state the player's in, make sure that's working properly. Okay. So let's see where I was with that debugging. So here, I was just debugging it, whether the actual right click was working. So we don't need that one. And we don't need that one. So tidy it up for now. That's just my debugging text. So let's keep that nice and tidy for the tutorial. Get them out of the way so you can see. Where were we? The dash. Okay. So there's a few things to this. When you press the right mouse button, it does dash, but obviously this stays true. So basically, if you hold it down, it will just continue to dash, and we don't want that. We want to actually have to press the button. So soon as we go into the dash state here, we can instantiate this to be false. And then while I'm in the dash state, if I click again, I want it to sort of buffer the next state to be another dash. A lot of games I've noticed have this, and it just feels a bit more dynamic. You don't have to sort of mash the button and wait for it to finish to do another one. If you click while you're in that state, it will just do another one next time. So we need to buffer that right click if it happens in the dash and return another dash. So easy solution to this. We just need a variable that I'm going to call dash pending, true or false. Standard it's false, but if we right click while we're in this state, then it will self.dashPending equal to true. So here, if it's the end of the dash, where the timer is less than or equal to 0, if self.dashPending is true, then I want it to return not idle, but dash again. Else, return idle. And that should do the trick. So if we run this, we're not actually dashing yet, it's just representative as the player stays still. So if I right click twice, then it lines another one up for the second time. Okay, no, take my word for it, it's not. Let's figure out why. So, self.dashPending. Because I've not actually determined when dash pending is true. And that would be in this enter state method. We put all our inputs, it'll only register inputs from here. Right click, and then self.dash pending is true. So that should work because it'll make dash pending true, and then it'll return dash if dash pending. So right click and again, and it does it twice. Right click and again, and it does it twice. So it stacks them up quite nicely. So let's get the player moving. So how are we going to do this? We've got our timer, our animation. So we don't want that to equal to nothing. We want to give a velocity in this dash. So I would like it to go towards the mouse direction. So it's totally up to you how you do this, but this is basically it's how I played Hyperlight Drifter on my laptop, and this is how it worked for me for the entire game, and I liked it. So it just points towards the mouse direction when it dashes. So I need to get this vector from the center of the player to the mouse, and this is how I did this. So I want to make it just call to one function to give it that velocity vector, and we'll normalize it to 1, and then we can times it by the speed just like we did before with the physics. So let's go into the player, and I just want to add another function here. This is unique to the player, so I'm going to put it in here. If you want other characters or NPCs to have it, you can put it in the character class, and of course it will inherit. But anything that's unique to the player or the class itself, I tend to put directly in there, so I know, and keeps the code organized for me at least. So let's call this vector mouse. Awful naming convention. I'm sure you can think of something much better. Self, of course, and I'm going to pass the speed in here. So when we call this function, we can just give it the initial speed. So for this, I want to calculate the direction towards the mouse. So remember, we imported vector2, math.vector2 as vec. So for this, what I want to do is, so the vector of the mouse position, so that's one vector, simply minus vector of the center of the player minus the vector of the camera offset. So remember, the mouse position just tells you how far it is from the side of the screen, but our player position is how far it is from the very edge of the level. So we have to subtract in both the X and Y how far across the offset is. So hopefully that makes sense to you if you've been following these tutorials and exactly what these variables are doing. And we can get that camera offset by doing this. So we've got the scene in here. We can call the scene camera offset. That gives us that value. I think that should give us the correct direction. And then you can't normalize a vector of length 0. So if the direction is more than 0, then I want to be the direction normalize in place. And then we just return the direction times the speed. And that should be a nice one-liner we can just put into our dash to give a velocity. So when we go into the dash state, just going to replace our player's velocity with a local velocity variable for dash, which would be our player, because we're getting this function here. Player dot vector mouse, and I'm going to give it a velocity of 200. And then at the bottom here, self dot velocity is literally equal to the character velocity. So we call this character in here, this state machine, for the character. But in the player, I want to call the character. So if I look up character, find all, and I'll just change that to player. I have to be careful, as up here it's changed it as well. Still want to get NPC from the characters folder. So now it's just player. So I think that's a bit tidier for this state machine, differentiates it from our generic character NPC class. Can probably just call this NPC. So yeah, player vel is now replaced with the velocity we've given in the dash. But we've not called the physics yet, so the velocity won't actually do anything. So let's see what happens. Only manipulated in the physics method. So if I right click, so more than vector to an integer. So I've got something wrong there in this method. Length. Length is more than zeros. We just want to normalize it, which will make it just equal to 1 in that particular direction. So there's no length as such, and 1 we can times by the speed to give it the speed that we want, but as long as it's going in the correct direction vector. So let's try it now. Same again. Physics is not being called. So there we go, still stay still, click twice, stay still twice, and then we're moving again. Let's make it move. So something to note here, we have to, before the physics is called, we do have to reset. Sorry, before the velocity is set here, we do have to set the acceleration to 0. So let's call the physics dt, and remember we're going to give a friction. So this was the standard friction, but I'm going to give it less of a friction, so it's got a smoother movement. So instead of -15, I'm just going to give it -5. So then if we do this, it'll actually, I think, point in that direction and fling left and right, forward and back, because we're not actually, before the velocity is set, we're not making acceleration 0 every time. So let's try that. I think it will just ping about. A bit crazy. Yep, there we go. So it tries to move, but it just flings forward and back on its own. So if I go player.arc, vec, remember that's just a vector of 0 and 0. So that just resets the acceleration before the velocity is called on every frame on this update function. And then there we go. So wherever I point the mouse, right click, and it will just nicely slide there. And you can play around with this. So for example, sorry, don't like that. Just need to call it character friction instead of -15 because that's my standard friction value. There we go. Or frick, sorry. Yeah. Back to the player. Getting distracted, sorry. Right, so we can give it even less. Let's do -2, and it should slide for longer. So the initial velocity here is 200 in the direction towards the mouse, and this is the friction that's applied to it. So there we go, slides for longer in the perfect direction of the mouse. Same again, click twice quickly and it will append the next one. Put another dash in the buffer. Set this 0, so it just continues at that velocity constantly until this timer is out. So let's reduce the timer a bit, make it half a second, and it should go at that velocity until the timer runs out. There we go. Doesn't slow down at all. So hopefully you can use that for attacks, dashing, for many different things. That'll make it very versatile for different states and actions you want to do with the player. So the attack, I usually just give it a little bit of forward momentum, just so it slightly moves forward a bit. And apart from that is I would probably instantiate, if this was an attack state, I'd probably just instantiate the hitbox for the relevant direction in here. But I'll let you guys figure that out. I've done it before. Hopefully this is enough to get you rolling with it. Okay, thank you. And for the next video, I'll show you how to do room transitions, because this took a little bit longer than I thought. So I'll make this a video in itself as just an extra to the State Machine video. Okay, bye-bye.